Good morning, everyone. I'm K. Nitish, roll number 2495580306. My topic is about crane wire rope fatigue. Crane wire rope fatigue refers to progressive deterioration of the rope due to repeated bending, loads, and unload cycles during operations over a time. So, crane wire fatigue. That means that the wire of the crane is damaged or gone to the failure. This generally happens due to very heavy loads, repeated loads, or any bending movement. So over a time it gets weakened and it is fatigue. So over a time it leads to development of micro cracks and eventual breakage of the wires within the rope, which can result to the dangerous failure if not detected earlier. So this fatigue should be this fatigue is generally happening. So we need to every time checking and do maintenance too. And if we detect and it should be detected earlier, nor else a very dangerous damage can occur. The very key points influence the rope fatigue are bending over sleeves and drums, load cycles, rope structure, lubrication, alignment and weaving, environmental factors. So now we'll come to know about these key factors in depth. Now, bending over sleeves and drums. Each time the rope bends over a sleeve or drum, the wire inside experiences stress. Next is small diameter sleeve increases bending stress, accelerating fatigue. Next is load cycle. The more frequency a crane lifts and a low loads, the fast fatigue sets in. High circle, low load conditions can be damaged as a low circle, high load ones. Rope construction. More ropes with more wires or more flexible or resist fatigue better than those of a fewer thick wires, for example 6 into 19, which have more abrasive resistance. Lubrication. Proper lubrication reduces internal friction and corrosion, extending the rope life. Alignment and weaving. Poorly alignment sleeves and misreeved ropes can cause the uneven loads and increase in wear. Environmental factors. Exposure to moisture, chemicals, or extreme temperature accelerates the fatigue. Next, we come to know the signs of the wire rope fatigue. First is broken, especially in the valley between threads, worn strands, kinks and bird caging, rusting or corrosion, loss of diameter. So here the water we can see the signs while inspecting. These signs are very essential. So we can see where they stands. Stands means the groups which combine and become a big group. Next is rust and corrosion. So by seeing the rust formation and corrosion, this generally occurs due to lack of lubrication and excess of moisture and loss in diameter. Best practices to minimize fatigue. These are the very essential practices which can easily minimize the fatigue. First one is regular inspection. It can be visual or tactical. It can be also a ultrasonic also. So regular inspections can lead to prevent the fatigue. Replacing ropes at recommended intervals. So the do not extend the lifetime of the rope. This extent, the fatigue is generally high due to more often usage, more use proper sleeve size and groove profiles, maintain good lubrication schedules, avoid shock loads. Avoiding shock loads also is very useful to minimize the fatigue. Next is progression of fatigue damage. These are of three types: earlier stage, middle stage, late stage. This earlier stage, it can be generally used. Middle stage, you need to change. The late stage, this is generally broken wires or damage occurs. So the fatigue should be generally infected or it should be solved between early stage and middle stage. Early stage. Now we come to know that how are these stages classified according to the fatigue. Earlier stage. This is internal micro cracks in the wire. This does not generally visible to the naked eye. So see now second one. No visible signs, but scent is slowly degraded. Middle stage. Small wire breaking in the valleys between strands. Often a few broken wires pay lay lengths. This is the middle. Small wires will be broken between the stands. Next, last, under late stage. Multiple broken wires, deformation, that is bird caging, kinks, sharp drop in load carrying capacity, risk of root stage. Next, these are some inspection standards and criteria. ISO 404309 2000, that comes of 2017 guidelines. Broken wires over 6 rope diameter. Maximum of 9 broken wires exceeds the limit unnecessary to the rope replacement. Broken wires over 30 ropes. Maximum is 18 broken wires exceeds this limit unnecessary rope replacement. Now we can see here the in the PPT the ISO standard and its certification for the ropes. This ISO 4309 is generally for the rope, ropes, wire rope, rails, and care and maintenance and inspection. Example: if 4 broken wires are found within the first 60 and 4 in the next 60, the rope should be discarded immediately. This is one type of inspection. Now, second type. This is OSAHA 1962 1413. This is one of the standard. So here we can see the inspection, wire inspection in the figure. Criteria 1. Decisions more than 2 broken wires in one rope, laying location below end connection. Diameter reduction of more than 5% for nominal diameter. Core presence of another distortion indicating core failure. Broken stand. This is the second criteria. Corrosion or abrasion, hinging, bird caging, severe failure, severe wear and fatigue, improper lubrication. Third criteria deficient. Priority electric connections with the power line. Several corroded unbroken wires at end connections. Best practices to manage the wire fatigue. Regular inspections, frequencies, focus area, and lubrication. Now in focus area, repeated e- wear sections, reverse bends, equalizers, sleeve, end connections, sleeve drums and grooves, wear and next is lubrication. Important. Regular lubrication reduces the internal friction and corrosion, extending the rope life. Methods. Applying lubricant to the rope at regular intervals, ensuring the fittings between the strands. Proper handling and installation. Avoid shock loads, correct installation, and maintaining records. Conclusion. Now, I hereby conclude that crane wear fatigue is caused due to repeated loads and load cycles, leading internal damage and eventually the failure. Regular inspection, proper lubrication, adhesive, and following the IS from some standards can be minimized. Thank you. Thank you so much.